Video number 5 about active filter of n order. I will first try to find myself a laser pointer so that you better can follow. So when we design higher order low pass filters, we normally cascade a first order section if we, for instance, want to design a fifth order filter. So a first order section, then two second order sections. When we look to this fifth order filter design I have here, we have the specification of it. It's the corner frequency minus 3 dB. We have 50 kilohertz, and the DC gain is A0 is 1. And we want to have a Butterworth filter, so a maximum flat passband. We select the first capacitor to be 1 nanofarad, and the second section here for this one, we select 820 picofarad, and the last filter section will get a capacitor of 330 picofarad. So let's get started by designing the first order part, where it has a value of A1 of 1, and as we know, a first order has a B value of 0. For the other sections, we have these values we will apply. And we can see for those second order section B2 and B3, they are 1, but have individual A values. So going back to the design of this one, we know from previous examples that we can calculate A1 based on this equation. Since A1 here is actually 1 from the filter table, and we have the F corner frequency to be 50 kilohertz and the capacitor to be 1 nanofarad, we apply that to the equation and find that R1 becomes 3.18 kilo. The closest 1% value is 3.16 kilo, so we have to use this in our filter. When we design higher order filters, we have to be sure that the resistors are 1% resistors, and the capacitors should at least be 5% capacitors, so that they affect the tolerance, affect the filter the minimum. Let's continue to the next design. That's the first second order part here. And we apply the Salin key with unity gain, so there's no gain in this part of it, so we use a buffer. And the first thing we do is to calculate C2 based on this equation, and we find out, applying the values here, that we get 1.26 nanofarad. The closest one we can buy is 1.5 nanofarad, so we will apply that in our calculations. Here as C1 and C2 values, you can see them down here when we put them into the equation for R1 and R2. The selected value is used, not the calculated value. Calculating R1 based on all these numbers, we find that we get 1.887 kilo ohm and 4.42 kilo ohm. They are actually locally 1% resistors that we can get, so we simply apply that for this order, filter order. Now, then the next calculation is for the last second order section. And again, we use the same setup, the same equation for calculating C2, but now based on the table values for this section. And we calculated that C2 becomes 3.46 nanofarad. And the closest value we can get is 4.7 nanofarad. Here you can see the reason why we select a low value for C1, because of the filter coefficient actually makes the capacitor C2 quite large, almost 1000 times larger. So if we would have selected this value up in the nanofarad, this would perhaps go in the microfarad, and for active filters this is not very clever to do, because bulky capacitors have long leads and some parasitic inductions, so we could actually get a hard time um, making the filter in reality, because of the capacitor C2 becomes very large. Again, based on our calculated values for the capacitor C1 and C2, we use the equation here as we saw in the previous example, and find that R1 is 1.45 kilo ohm, and the closest 1% value is 1.47 kilo ohm, and R2 is calculated to be 4.51 kilo ohm, and again using 1% resistors we get 4.53 kilo ohm. So now the filter is actually designed, and the overall setup is like this, with the first order section cascaded with the second order we have calculated, and the last section. So this is a fifth order, but before we can say that this design is actually ready, we actually have to check the overall characteristic by a simulation. Calculating is not always enough. Because of the rounding of the values, we could have some surprises, and perhaps we have to go back and recalculate with another capacitor values a better design, so that we are not surprised that hoping to get a Butterworth filter, but we actually, based on the actually selected tolerances, we actually get a Chebyshev filter. So this is the example of higher order low pass filters. Thank you for watching this video.